back. We're making breakthroughs, people. Alright, this is where we left off. We're able to draw the Star Fox spaceship in 3D. However, there's no depth detection, so the triangles just kind of draw on top of each other in a random order. We do have something called backface culling, which means that it's only showing us the triangles that are facing our direction, which is nice. But it's not drawing them in the right order. But I did some reading today, and a lot of drawing on paper, and I think I know what to do from here. Also, here's what the wireframe looks like. You can see there's a little Star Fox guy inside. Alright. It all starts with this triangle. I'm gonna try to properly color this triangle using something called barycentric coordinates. Let me just show you an example. Yeah, this is what we're trying to draw. Starting from this. How's it going, Kartarva? Welcome. Alright, let's just start with our fill triangle function. Let me think about how I want to do this. We need to turn each leg of the triangle into a number between 0 and 1. I'm doing pretty good. Just having fun learning some 3D graphics, trying to make a little 3D engine from scratch in my spare time. Otherwise, been working a bunch on the little guy's game. Releasing minor updates here and there. Okay, let's try something like this. Render that, see what that looks like. Alright, this is a start. We're going for this. That's what we're going for. You're planning to learn to code in C? Awesome. Yeah, C's a fun language. It's like... It's a small language, there's not that many features compared to, you know, more modern languages. The hard part is that you have to literally poke around in the computer's memory. And it gets real messy down there. Let's see here. I'm consulting my notes for this. Let me just say that's what we're working on right now. We're going to try to improve on this triangle. Yeah, we got a triangle. It's blue. Alright, we got this other... I need to turn the other leg of the triangle into a number between 0 and 1. Let's see, I want to do something like this. This looks right. And then the other leg of the triangle. And then I need to swap these, I think. Okay, last thing. I need to know how far along we are on the X strip, which goes between start X and end X. Oh, that's easy. X minus start X divided by end X minus start X. Okay, and now we just got to combine some things here. You are those numbers. Oh, that doesn't look right. Okay, now we have to combine these. Yeah. Yep, okay. No. No. Multiply the first edge by this number. No. Second one, add these two things together. I would slow down to explain this, but you know, maybe I will actually. People are interested. But for now, I'm just going to get these colors on the screen. So what we end up here is we end up with the barycentric coordinates. We're basically plotting a point on the triangle in its own coordinate system. Is this correct? We're going to find out. Now that we have these three numbers here, we can actually turn them into colors. So that's one channel. That's kind of like all the blues. This is actually looking right so far. One corner is all blue, the other corner is kind of blue, and the last corner has no blue in it. And so we're going to do the same for red and green, but basically rotated around the corners. And yes, we're using 4-bit color for no reason. Or rather, I guess it's 16-bit color. That doesn't look totally correct. Yeah, something's wrong here. That's not exactly it. Let's see here. A, B, C. This looks okay. Maybe these numbers are wrong. Oh. Yeah, that was it. Yeah. Okay, cool. So this is great. Let's use this on our Star Fox model. And so now there's no depth detection yet, but at the very least we can see each of these triangles are correctly mapping the colors across the triangle. And so we can use this for texturing, and we can use it for depth detection. So we stop getting these weird overlaps. Pretty awesome. Alright, I'm just gonna have this guy rotating in the corner. So let's think about how we're going to get rid of these overlaps. It's hard to tell if the overlaps, but it is a spaceship. Here's the wireframe. Yeah. It's from Star Fox. Or at least someone made this and modeled it after Star Fox. There's a little fox in the center, but you can't see it when I fill in the triangles. So let's do this. When I fill the model, I project these 3D coordinates. Let's do the projection inside the triangle function. Let's see. Yeah. So now we're going to take in the 3D coordinates. in the world space, and then project them onto screen space. Yeah, so we can get rid of this. Make sure that still works. Let's see, 1, 2, 3, 1, 2, 3. Yeah, I changed the definition of this function. Okay, still works. Okay, so what I want to do is whenever I draw a pixel, I want to double check the depth of a given triangle from the camera's perspective. I can use that. I can use the same barycentric coordinates, I believe, on the original points of the triangle. Something like this. X, Y, Z. And then this gives me, let me think. Yeah, I think I just add all of these together. Excuse me. What? Why did I call it that? Okay, so now we actually get the point of the triangle in world space. And so if we want to hide triangles behind other triangles, we need to keep track of the depth of every single pixel on the screen. So I'm gonna have to create that now. Let's make that a list of floats. Call it depth, or I could call it a Z buffer, but whatever. And yeah, let's just initialize it. Oh, wrong programming language. Okay. Allocate some memory and then free it. Don't forget to do that. And then we should initialize it to all zeros. Or maybe all ones. We'll figure it out. I'll just initialize it to 0 for now. kind of just making this up as we go. Okay, so now we have the depth. In this component. Okay, what if I was just like... just check whatever current depth we have. And so, let me think. We're facing forward, so I expect... larger values will be in the distance. So I might want it the other way. Make it do a barrel roll. We could probably do that. It's not fully rendered yet. There's a couple more things we need to do here. Okay, let's try this. So if the depth of this triangle at this pixel is less than the current depth, draw it and then assign that depth. Ooh, and then let's clear our depth buffer when we start rendering. And then let me make sure I update the headers. Okay. Yeah, and then I need to add the depth here. Oh, beautiful segmentation fault. All right, let's make sure we're... Oh, I never assigned the... No, I did. malloc, width times height, number of floats. And then we just set that all to 0. Make sure to set this all to 0. That all looks good. Will it die if I render nothing? No, okay, so it's clearly happening in this model drawing function. Probably in the triangle function. Ooh, it's growing, it's getting big. Okay, and then we index this guy, y times width plus x. That seems okay to me. But it's not. Do a good old printf. Is the model just hard-coded? No, actually, we're loading a file, an object file. Dun, dun, dun. Yeah, just a bunch of vertices, and faces. So we just load it up real quick and try to draw it, basically. Oh, maybe I didn't update this function call. Oh, dude, we're so close. We're so close. We're getting somewhere. I think I know what's happening. Okay. I think I can tell what's going on. We initialize our depth buffer to 0. So I think it's only giving us half of the model at any given time. That's what it looks like to me. So I gotta reevaluate what we're doing here. Still a bit of clippage going on. Here, let's get rid of this RGB color scheme. So it still looks pretty busted to me. Like some parts look okay, like this side of the wing looks alright. This thing looks okay. But it's still like phasing in and out of each other. And you can see a little Star Fox head inside. Which book, Antonioni? Is it that one rendering book? Yeah, that one. That one's cool. That one's the reason why I was able to do something like this. Pretty much everything you learn from that is going to teach you everything for this. Also, I thought it was pretty funny that I didn't realize I posted this publicly because I ended up getting someone commented on it and gave some very helpful suggestions. Apparently this is still very inaccurate to real life. But they gave me some good directions in the comment. Hello, Zeep. Welcome. Dang, so this is like kind of working, kind of not working. Maybe I'm not computing the world coordinates correctly. Am I planning on making 3D games? Not really. This is mainly for fun. And I just want to get better at graphics in general, like computer graphics. Although there is a game jam, the Pirate Software game jam is coming up, and I actually want to enter that. It's a 2-week game jam, and I kind of want to do some 3D stuff for that in my spare time. My sole project is the Little Guys game. It's my main project. Let's just look at it head on can see that there is some depth issues. So I wonder why that would be. Oh, I know why. Or I have a good idea of why, actually. It has to do with the fact that I'm sorting my vertices. That's messing it up. Yeah, okay. So I need to sort these, I need to sort these as well. That's interesting. Alright, well, let's just... make our function bigger. Ooh, are you talking about the invisiwalls? I just learned about those in Mario 64. How every level is plagued with invisible walls in the most, like, innocent places. Okay, this is a cool function, but I'm gonna move it to my rendering file. Sort vertices by Y. Da-da-da. Okay, so now when we call this function, it's gonna sort my 2D screen coordinates and my 3D world coordinates. Hopefully that does something. Dun, dun, dun. Yeah. Please work. Please work. Need to save this other file, I think. Make clean. Why is it freaking out? Oh, awesome. Why is this in there? Get that out of there. And then clean. Rebuild. What's going on here? Now we're just having regular C problems. We're so close. Oh, I just didn't define that function ever. That's awesome. Sure to define things. Just in general. Don't forget to define things. Okay, a little bit better. Just a little bit better. What graphics API? Or is this CPU rendering? This is CPU rendering. I'm gonna just do it all by hand. Because I realized that I didn't really know what, you know, the graphics card does. Or what OpenGL does. I vaguely know. I don't really know. So I figured the best way to learn would just be to make a CPU renderer. Okay, let's try to rotate the thing again. It's like, it's so close, but there's still these little pieces that are still overlapping. Maybe the model is just broken, but it's a lot closer. Am I taking a break from Little Guys? No. I worked on Little Guys today. And yesterday. This is just for fun in my spare time. What is this? Trying to make 3D from scratch. Trying to code 3D. It is the ship from Star Fox. There he is, Mr. Star Fox himself. He's in the ship. Can I explain why CPU rendering helps understand what the graphics card is doing? I mean, yeah, like, there's only one way to draw a triangle. Well, okay. There's a very specific graphics pipeline. Like, the life of a triangle is very well defined, and it's something that all graphics cards do. All graphics cards follow the same steps of making 3D space, drawing triangles, coloring and shading the triangles, and adding a bunch of effects. And so I'm trying to understand it by coding it, as opposed to graphics cards, which hard code it with hardware. Like, they always follow, like, there's this pipeline of steps that graphics cards will follow. It's always the same, or more or less the same. And I would just like to understand it better so I can use it to its fullest potential, I guess. Is that Star Fox model available as an OBJ? Yeah, it's right here. I downloaded this from the internet. I should definitely give credit. It's not from the game, it's... I'm trying to remember how I found it. I think it might be this one. Yeah, it is this one. This is the one I'm trying to draw, I think. I'll just put that in chat. Arise, see by using ray tracing. Yeah, pretty much. Or like reverse ray tracing. We're still getting weird, like sorting problems. We do this thing, project it onto the screen. We just stretch it out to fit the screen. Then we sort our vertices. And we get the coordinates. You want to make a little guy's 3D model? Go for it. Ooh. Yeah, just a little bit of clipping. Hang on, wait, some of these triangles don't look right. Yeah, wait, that one's all messed up. Ooh, okay, I think I know what's going on. Yeah, okay. We're not getting, this thing. Interesting. So some triangles are mapping their coordinates correctly, other ones are not. This green part shouldn't just be right in the center here. Whoa. Interesting. All right, let's fix this. Let's just put another triangle on the screen. Let's put it at x 0. Let's flip it around. Okay, cool. So we got one correct triangle. That looks good, but this one's all wonky. Yes, it's late for some of us. I mean, it's late for me too. It's 11 p.m. I got work tomorrow. But I'm determined to finish some work here. Got some unfinished business, namely this triangle here on the left. Let's see here. Yeah, I am a sucker for YouTube on the couch and falling asleep. It's a problem. It's an addiction. Alright, so what's going on here? We get red on this top corner, which is correct. Then blue is the lowest point here. Here, let's just do one channel at a time. Red, green, and blue. So it's acting like there's two triangles. That's interesting. Oh, that's pretty. Yeah, it thinks there's two triangles. One here and one here. Ooh, that's so weird. Okay. Thanks for stopping by, Antonioni. Always a pleasure. Let's see, so this is happening in this area. So something here is probably wrong. Say this point minus this point. Alright, I'm just gonna do something random here and see what happens. Oh, okay. It does nothing. No, of course not. minus the middle. Yeah, that's okay, I think. There's definitely something with this. Unless this is all messed up. But I think this is okay. Okay, what about this? Start from here, draw to here. Multiply this by that, this by that. Wait, what happens if I swap these? Huh. Now it's super messed up. Oh, now it looks correct. Oh, wow. So they swapped. So what do I want? I want red to be the topmost point, then green, and then blue. If I swap these numbers, get red, then green, then blue. Okay, alright then. I just need to tell, or be able to detect, what kind of triangle we're working with. And then swap these two numbers accordingly. Alright, that's not bad. And just to better test this, oh, that doesn't look good at all. What? Definitely some issues here. Let's get rid of this depth stuff. Really? My projection function is all messed up. Or maybe I'm just trying to draw impossible triangles. Oh yeah, I was drawing triangles off screen. Interesting, yeah, I gotta... Let me write that down. If I try to draw triangles off screen, they like fold and look all messed up. Okay, but we can kind of see the problem here. It looks okay, and then it doesn't look okay. And let's do the same for the other triangle. So this has to do where the bend in the triangle is. Whenever it changes the topmost point on the triangle, it switches from being ass to being okay. So let's fix that. Basically, I just want to detect where the bend is. Yeah, probably something like this. Definitely don't want all these if statements inside these for loops, but we can optimize it later. Make sure I'm not accidentally sorting these. I am sorting them, so let's see. There's a smarter way to do this. Perfect. Yeah, okay. Good. This is what we want to happen. We're accurately getting the coordinates on the triangle, the triangular coordinates, where the topmost vertex is red, the middle one is green, and the bottom one is blue. Okay, let's draw the model again. And then let's turn on the depth sorting. It looks a little bit better. Still tiny little graphical glitches, but it's a lot more stable. This is actually much better. Am I the guy that streamed the long dark game? No, I have not. I've not streamed such a thing. All right. Let's go back to drawing the coordinates. So for some reason, if I try to move the triangle off screen, it starts to fold for some reason. I think I see what's going on there, actually. It's because I'm taking this value and I'm limiting it. So what I actually want is to clamp it once. There we go. Now we're drawing triangles off screen. Okay, and we can reuse this value. Like a million other places. Yep. Oh, I messed it up. Wait, how did that break it? That's that value, that's that value. And that kills it for some reason. That's very weird. Okay. If it put that number there, it dies. What? Wait. That doesn't make any sense. I guess because this is a float. Oh, yeah. And I want everything to be floats. Yep. Got it. Make everything afloat. Okay, beautiful. Alright, and then does it render to the left of the screen? Good, good. Good. Yeah, it's doing okay. Still just a couple issues here. Oof. Oops. Okay. off that wireframe. We're so close. There's just a lot of tiny little issues. Just like a little bit of overlap. Let's draw some more models. Got this other one here. It's a Quake model. I just gotta parse some of these texture coordinates. Alright, we're gonna change our model loading function to handle texture coordinates. Right now we're doing it this way. It kinda sucks. Actually, what happens if I do this? Does this model have any quadrilaterals? No, I think it's all triangles. That's good. Let's see if this still works. I just want to double check here. 1, 2, 3, 4, 5, 6. And then let's load. Where's my guy? Quake. Hello. Okay, so it gets 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh yeah, I think it actually just worked. I have to zoom out though. So let's do this. Make the model smaller. So all the vertices are between. Oh wow, like negative whatever. Okay, I think I'll just try to get the smallest and largest values along each axis. Yeah. That's too close, I think. Oh, there's a model or something. Here, let's do this. Scale. Yeah, okay. Okay, there he is. All the way in the corner of the screen. That's awesome. So now I want to translate it. Let's just do this. I guess I want to move it a couple points to the right, a couple points down, and yeah, maybe something like that. But first we rotate it and then we translate it. That seems like it makes sense. Okay, gotta move it a whole bunch more. Nice. And let's not make it so small. Huh? Where'd you go? Where'd you go? Oh, I see. Yeah, I'm scaling it kind of weird. Here, let's scale it earlier in the process. Right, so there it is. And then let's scale it here. Yeah, scale.x. Right. No. Just make scale a float for now. Okay, cool. And just scale it down some more. Okay, the scale is affecting the positioning, which is definitely not good. That shouldn't be happening. Last thing I do is translate it. First thing I do is I scale every vertex. Maybe this thing just isn't centered, which would be kind of crazy. I guess that's possible. Let's see. I get the 3 points on the triangle. I scale it. Then I rotate it. I should probably rotate it and then scale it, actually, now that I think about it. Maybe. It changes nothing. Alright, there's our guy. So most of these triangles are looking pretty good. A lot of them have these weird artifacts. You can see little horizontal lines poking out. There's also some Z fighting. Adjacent triangles can't decide which triangle to render. Kind of get this like zipper look. It's not bad, not bad. Maybe we'll fix some of those triangles. They seem pretty common. Why would I be getting a segmentation fault? Oops. This guy's got so many triangles. Let's see. These ones look okay. Actually, you know what? Let's add some camera movement. That way we can inspect things a little bit better. Okay. Yeah, okay. So let's do this. Draw model, let's give it like a center position. And then some rotation angles, and then like a scale or something. We're still drawing this in an orthographic projection, so there's not a real... It's gonna look more flat than it would in real life. just some very crude input handling. Scale, scale. Fill model flat. Yeah. Okay. Yep. So now let's take this and let that be our nice. I think I rotated him too hard. Oh, gotcha. I never set this to false. There you go. And so let's limit the FPS when handling input. Just make this look a little bit nicer. Okay, not a pointer. Okay. Just setting some stuff up here. Here, let's just toss in the game state. Actually, no, bad idea. Okay. Couple more things. Just gonna handle all of the game logic. I mean, it's not a game, but handle all the logic in here. Still works okay. Now I just want to limit the FPS. So basically, I want to render as much as possible, but only update once every however many milliseconds. Yeah, SDL get ticks or something. Number of milliseconds, okay. So basically, I guess I just want to ask if the current time minus the last time is about 16 milliseconds. Update. Okay, that should keep the frame rate for updating consistent. Ah, there he is. Okay. Yeah, that looks okay to me. So now, when we draw the model, I want to be able to move the position of the camera. Okay, let's check some different inputs here. Turn this into a big switch statement. Actually. Okay, press A, press B, or sorry, D, rotate to the right, then left, yeah. Yep. Here we go. Left, right, up, down. Up, right. Okay, and then do the exact same thing when we release a key. Just set all of these things to false. Great. Handle key up. Handle key down. Beautiful. All right. Then if we press left, we can let's see here. Up, move down, just translate the position. See if that does anything. Ooh, and we forgot our break statements. Love switch statements. Offset. Yep. Okay, just gotta update the fill triangle function. This takes an offset now. Yeah. Okay. Let's increase the speed. Still pretty slow. Oh yeah, I guess it is pixels. There we go. Okay. All right. And now let's do one more thing, which is rotating in a completely different direction. Okay, we're gonna add 2 more keys here. W and S. Beautiful. Do it again down here. When we release the key, and then add those to our game state. Awesome. Now we have to use it in the model function, so we have our pitch. And so what I'm thinking is, we have this cool function to rotate a vector basically around the y-axis. We can do it again. Let's rotate it around the model's z-axis. Yeah, okay. So what's the, how would I do that? I'm gonna leave the z-axis alone, basically. And just rotate. No. I want to rotate it around the x-axis. I'm stupid. Yeah, this is what we want. Let's be rotating Y and Z. And so what is this angle thing? There we go. Let's just see what happens when we rotate first around the y-axis and then around the x-axis. I'm sure the order matters, but... Oh wow, no, that works just fine. Kind of gets squashed in in this direction. Huh. Wow. A lot of weird triangle artifacts, which we have to fix, but wow. That's pretty cool. I'm not seeing any obvious problems other than the weird horizontal lines. Yeah, there, here and there. And some of the Z fighting on the edges of these triangles here. Otherwise, this is like surprisingly like kind of working. Okay, yeah, we'll try to fix those horizontal lines. They're pretty prevalent. You look so goofy from some angles. Ooh. Okay. Let's isolate some of these triangles. And then find out, I guess, what the deal is. Got 400 triangles. That's awesome. Also, can we still render the air wing? Might have to fix that. We still got Quake guy. Okay, 400 triangles. Let's just go in and try to narrow some triangles down. Okay. Yep, got some weird issues there. Oh yeah, definitely. Seems like it's only happening for triangles with a flat base. That's what it looks like. Like a flat horizontal base. And it doesn't actually look like it's happening when it's flat at the top. Oh. But it happens when it's flat at the bottom. Okay. Yeah, that's a fun edge case. Let's try to fix that. Try to get a very extreme case here. Yeah, this perfect. Okay, I'm gonna keep track of these values. Then I'm gonna start the game. With those values. Perfect. Actually, I don't know if this is visible. Let me, because it is 1 pixel thick. Let me just make that a little more obvious. What we're trying to fix here. Triangles with a flat base on the bottom end up drawing these really long horizontal lines. So let's go into our triangle drawing function. So this would only happen on the very last line of the triangle. If I skip the last line, it technically solves the problem, but I don't know if that counts. think it has to do with the fact that it doesn't know which leg of the triangle to draw out to. That doesn't solve it. So what we have is that one point here is on the corner. The other point is way over here. Like, I don't want to just skip the last line of each triangle. I don't think I want to do that. Hey there, Nils. Thank you, thank you. I've updated the game a bunch since that video. Basically working on that game every day. Just doing some stuff for fun right now. Okay, surprisingly, that change didn't ruin the appearance of the models. It actually just made it completely better. Wow. Yeah, there's no holes in the model. Or maybe a little bit. Don't know what's going on here. Otherwise, it looks pretty good. Little weird thing right there. There's a lot of little weird things. Yeah. That's interesting. Well, for now, pretty happy with the triangles we're drawing. It doesn't look terribly bad. So I think we can continue and maybe try to texture this guy, perhaps. Okay, so it looks like we can load a PNG file. Yeah, okay. So I have this texture file. So I'm gonna try to map this texture to the triangles on our guy. Yeah, we're gonna see what happens. So let's see. This image load function. Is that real? I think I have to download SDL image. What version of SDL do I have? Let's do some stuff here. I need to know which version of SDL I have. And it doesn't like that because I have to include something. Oh no, gotta get rid of that. And then I misspelled printf. Version 2.28.5, okay, good to know. 2.28.5. Which is not the latest. I don't think that's the latest version at all. No, I think it is. I think it is. Alright, let me just extract some files here. Alright, alright, alright. Yep. And there it is. All right. Now we may proceed. Yeah, image load. Nice. And that just gives you an STL surface. So let's load assets quake.png. Yeah, but we get a pointer. And so I think I can just get rid of this. Draw the thing directly to the screen. I have to give it some coordinates. Oh wow, super readable. If source rect is null, the entire surface is copied. If destination is null, then it's upper left corner. Yeah. But I have to give it the destination surface. Okay. I think I have that. And this is like, don't do that. Excuse me. No, we're good. Doesn't like image load. Look at the make file. Oh yeah. STL, what is it called? STL2 image. And then clean. Do I have some kind of project organization for this? For this, I started coding it yesterday, and I'm still just kind of messing around, trying to get it working. I haven't really spent time organizing it. It's kind of organized. I've got different files. Got like the main file, a file for loading 3D models, a file for drawing, and a file for like 3D math. But right now it's very haphazard. Kind of just want to put something on the screen. Okay, so it's like, doesn't know what SDL2 image is. It's never even heard of it. That's weird. Wait, do I have to like... Hang on a second. Do I have to copy and paste this with the executable? So I do. Oh god. Flashing lights. Oh god. Okay, well, it's loading the texture, so that's good. So I guess now let's read from the texture. Yep, we're going to create a texture from the surface. That's what we're going to do. Yep. Okay, so we load the PNG, then we turn it into this texture. What is this rendering context? Okay. Okay, so that's what I think I want to do. I want to pass this to the model rendering function. Let's not worry about it. Let's just take the texture as a parameter. Just keep adding parameters. Don't stop. We're not really worrying about the cleanliness too much right now. We're just kind of, you know, kind of coding like ass. Just to get something on the screen. Okay, let's make sure it doesn't explode. Oh god. couple things here. This function, we should pass in the image texture. Good. Why is it still doing that? Oh, because I'm not rebuilding it. Okay. Then let's just include some stuff. Hang on, what happened here? There we go. Whoa, still flickering for some reason. Let's see what I did. I still lock the texture, unlock the texture, copy, present, update window surface. I wonder if this messed with it, creating this image texture. No, it's still flickering for some reason. That's very odd. Let's see, I do everything I need to do to the texture, the screen texture. I render it to the screen. And yeah. Update the window. I don't know what's so different about it. What is this? Window surface. Oh wow, yeah, that messed with it. Okay. Don't need that. Okay, it doesn't die. And then just double checking. I should still be able to draw the image surface. Oh, gotcha. That's the window surface. Okay. Alright, let's try to pull from this texture data. So actually I have to go into my model class, and then for every triangle, we also need to give it the vertex, the texture vertex coordinates. Which is awesome. And just looking at the OBJ file format, that's just another thing. UV coordinates. Yeah, list of texture coordinates. U, V, maybe W. Between 0 and 1. And looking at our model, yeah, it's just a bunch of UV coordinates. I guess we can store that as a vector too. UVs. Big list of UVs. Okay. There we go. UVs. Great, so now we have to handle that as a case. So add a UV if we are starting with the V and starting with the T. And so processing it should be pretty easy. Basically, we just need two floats right after another. Great. UVs, model, UV, or num UVs, plus plus. No, not plus plus yet. Actually, yes. UV. And expand the list if we have to. Realloc. Beautiful. That's how you resize a list in C. You just manually reallocate new memory. Great, so we get our thing. And then for the triangle, let's see here. Right, so the triangle has separate UV coordinates for each of these points. So what does that mean? We have 3 extra fields here. For VT2, VT3, VT1. Hang on. Yeah, okay. Let's just make sure it doesn't die. Okay, it does. Really doesn't like that. Let's see, we get a float, U, V, F for float. Use the addresses. Starts with V and T. Add it to our list of UVs, which we allocated here. Vec2 UVs. UV, and then we make sure we don't break the capacity, resize it, reassign it. That looks good. And then we set the UVs on the of the model here. Okay, let's just double check what we're getting here. The vertex texture coordinates. Oh, we don't even get anything. Probably busted around here, maybe. U and V. Okay, we get one. And then we store that in our list. Probably because we didn't initialize num UVs to 0. There we go. Classic. Can we make a little more progress? Gets all the way to... '85, '87, 106. Okay. I think our rendering function might be busted. Pass this texture to the model. Pass it through to here. Give it texture and amount. Good. Amount is used to color the thing. And then we color the guy. Okay, we don't do anything with the texture yet. That's good. Let's see how many triangles we draw. Oh, so it randomly seg-faulted. That's not good. That was very strange. Guess we're okay. All right. So now we have basically all the data we need. Now, when we want to get the color of the pixel, I need to find the points on our texture, then sample the texture at those points. Yeah, okay. Let's see here. So actually, I do want a reference to our model. Or, I mean, I don't really need a reference to the model. I could just pass in the corresponding UVs, I think. If I'm not mistaken. I think I can just do that. This is a beefy function. Okay, yeah, so if I want to get the UVs, that would be model.uvs, right? At triangle VT1. Yeah. There we go. We get our UVs. Okay. And so these are numbers between 0 and 1, referring to points on the texture. so I want to take these. I want to do something similar here, where I use the barycentric coordinates. Yep, except using vector 2s. V1. UV2, UV3. This function doesn't exist yet. Float. Scalar. Am I able to add? Yeah. Okay, and then, yeah. So what is this going to be? This is going to be an actual texture coordinate. I'll just call it UV. And then make sure we get this right. If that's okay. Can I override or overload functions in C? Oh, you can't do overloading. I didn't realize that. Did not realize that. I thought you could. Alright, cool. So now we just need to map these UV coordinates between 0 and 1 to texture coordinates. And that's not too hard. We just have to multiply it by the width and height. Or sorry, the width and height of the texture. So yeah, let's get that information from the texture. I'll worry about optimizing this later. There's so many opportunities for optimization. Okay, I think I'm going to do... I'm going to query the width and height. I guess that's all I need for now. Well, I do need the pixels too. I guess if the only thing I need are the width, height, and pixels. I don't need to pass in the whole SDL texture. width and height of the freaking guy. Here's what we're gonna do. I'm gonna pass in this struct. Okay, let's get the width and height. Nice. Model, render texture. Okay, just package all the things we need. Yeah, render texture. Oh yeah. Don't really need a pointer. Maybe we do. And then this is actually the image texture. Render H. Get rid of that. Get rid of that. Okay. I mean, nothing wrong with the pointer, actually. We'll be okay. Okay, so we have all this texture information. That's great. Now we can query it. Render texture. Yeah, texture. Texture dot width. uv.y texture dot height. And now what? Well, we want to get the pixel on the texture. I guess just this. Cast it to some integers. And that should be something. I don't actually know the pixel format, so I may as well query for the pixel format just to double check what we got here. Yeah, format. Pixel format. Yeah, bits per pixel. we got. Uh, 32 bits per pixel. Okay, yeah. So in that case, I need to convert each channel into... I'm only using 4 bits per channel, so 16 bits per pixel. Oh, and I don't know where it's placing the alpha channel. Yeah, I guess alpha mask. Okay, the last byte. That's good to know. Okay, so I need to convert this into a different pixel format. RGB 16:8. That. There we go, there we go. Okay. And now for each of these, I'm going to right shift it 4 bits. Yep. Then I'm going to say color is equal to A right shift 12, R right shift 8, G right shift 4, B. Alright, let's see what happens. Okay, we're not accessing the texture correctly, so let's just make sure we're getting the right UV coordinates. Okay, we've got a big negative number for no reason. So let's see what we got for each of these input UVs. Oh, interesting. Big negative numbers. That's not right. And so where do these come from? These come from the... God, this function's getting huge. UV1, UV2, UV3, which comes from here. UVs at these indices. Those should be vec2s. And so when we load the model, let's see, we get 2 floats stored here. Let's make sure we don't load anything funky. Oh, let me be careful here. I'm trying to print integers. Okay, there we go. Okay, yeah, normal numbers. Completely normal numbers. Okay, so 196 and 13. And then we round it down to an integer. Probably makes sense. The dimensions of the image are something. Does not look that big. Hey, okay, welcome back. It's looking pretty good so far. Let's, here, let me run it. I haven't run it in a while. Oh yeah, now I'm printing a bunch of stuff. Let me turn that off. So I'm drawing this little guy. There he is. Looking all right. I think all my triangles are looking okay. There's some weird artifacts, but for the most part, not bad. Yep. So now I'm trying to texture it. It's gonna take a little bit of work though, but I feel like I'm pretty close. So let's see here. Width and height of the thing. Let me double check the size of this image. Okay, it's supposed to be 296 by 194. Let's see if that's actually true. It is 296 by 194, perfect. Okay, so I should be able to get the pixels from this image. Image pixels. Image texture. Image pixels. Ooh. I don't know if that changed much, but let's see. Yeah. Pixels for what, you ask? Why, the main character of the Subway Sandwich Simulator, after all. This guy. There he is. See, he's got an axe for chopping up, you know, chopping up bread, and he's got a spare sub on his back. See you soon, okay? Why is it exploding? Why is... it's just falling apart, is what's happening. Image pixels... da-da-da... $12.80. That's in bytes, right? Please be in bytes. $296 times what, 4? Wait, something's not adding up. The width is 296. This, the pitch of the locked pixels. The pitch is the length of one row in bytes. Why would it be 1280? 296 times 4 is not. What's happening? Oh my god. Basically, the math ain't mathing. Oh, beautiful. I don't have to do any of this. I can just say STL map RGBA. Where I give it the pixel format. Target pixel format is this guy, right? Probably not necessary. Alright, what's going on here? What's going on here? What is this array index? 40, 44. So we try to access 40, 44. And it doesn't like it. Now we're clearly within the bounds of the image. Okay, it says this is write-only pixel access. Maybe I need another way to do this. How to get the color of a pixel from a surface. What in God's name? Oh, I can just get the pixels. Oh my God. I've been a fool this whole time. I don't need any of this. Get out of here. Don't need that. Don't even need this. Oh. It's not dying. It's not dying. Oh yeah, oh yeah. That was something. That was great. That's not exactly what we want. We're getting some pixels. For some reason, they're all blue. And then I rotate it and it explodes. Mm-hmm. I think the pixels are dumb. Oh yeah. Yeah, this helps. Yep, got it. Okay. Yeah, that was very helpful. What the fuck? Alright, what kind of numbers? Hey, what kind of numbers are we getting? I feel like these are pretty weird numbers. Alright, here, let's do this. If uv.x, here. Let's not be stupid. Let's be smart. Or u is greater than texture dot width, or v is greater than texture dot height. Just tell us what we get. Okay. Negative? Excuse me? Negative? You're telling me we got negative numbers? No. That's not possible. Negative? Negative numbers. You're telling me. Alright. Yeah, I guess I'll just ignore... What is this monstrosity? This is nothing. What is this? I wonder if I can even make out like what's from the model. I think I can. I think this part is this little knee thing. The rest of it is not so easy. Okay, and why is it all blue, huh? What are you blue for? Maybe these are actually supposed to be RGBA. Nope. So it is like getting the pixels. Maybe my math here is wrong. Shift it by 24 bits, 16, 8, nothing. Take out the last byte, right shift it 4 bits. Yeah. Don't know why it's blue. Why is it blue? Why are you blue? Also, I'm definitely not mapping the right coordinates. Okay, I think this super blue part is whatever this colorful thing is down here. Why are the pixels blue? Okay, good. So the alpha channel is correct. So it seems. Otherwise, we basically just never have any value for red. Which shouldn't be the case, because like this entire texture is like it includes a lot of red. Like there's no blue in this texture. Every single color here includes a tiny bit of red. Okay, I don't know why swapping red and blue actually looks better. Wait, that just looks accurate. What? ABGR? There's no way. You know what? I'm not even gonna question it. I'm not even gonna question it. What's up, Fix Fox? Alright, so clearly our UV coordinates suck. Oh yeah, and I have to swap them around in the same way I do here. Yep. Classic. This is going to be so inefficient, but, you know, we'll work on that. Yeah, 2 and 3. 1 and 2. And 2 and 3. Okay, this should look a little bit better. Yeah, a little bit. I think it might be upside down. I think I'm sampling it upside down. Yeah, it's definitely upside down. Maybe backwards too. So we'll just do flip the y coordinate. Oh yeah. Look at that. Nice. That's 3D. That is software rendered 3D on the CPU. Nice. Still some problems, like some weird stuff going on with his chest and legs. It seems like at some angles the triangle coordinates are still super messed up. But yeah, we can fix that. For the most part, it's looking really good. Okay, this is awesome. So now we can combine this. We can combine this. With our little lighting effect. There we go. That was kind of lit. Beautiful. Still a lot of sampling issues. Nice. we go, just a little bit of a lighting effect. Nice. Wow. I'm very happy about that. I should call it quits here. It has been 3 hours. But, wow, this is a pretty big jump from the start of the stream. Very happy with this so far. We just got a guy on the screen. Nice. Alright, well, I'm gonna call it there. I think we did a really good job today. Still plenty to do, but, you know, we're learning. Alright. Thanks, folks, for sticking around. I'm gonna end the stream. Probably gonna stream more often. Either doing this stuff, learning 3D, or working on little guys. By the way, there is a Steam page where you can wishlist little guys. Let's not forget. Wishlist little guys. I'll see y'all later.